Hey, how are you doing? Today I'm showing a mini SOC investigation in my lab using one correlation tag to stitch evidence across Splunk Windows Security Authentication logs, if you remember Event 4625 from the previous video, JuiceShop nginx application logs, and Microsoft Defender for Endpoint. The goal is to prove correlation from the endpoint layer to the identity authentication layer to the application and network layer in about 5 or 6 minutes using a single tag, with OpenSense firewall sensors available as an optional deeper pivot. So I'm about to run a control the burst that stamps one correlation tag across OpenSense, JuiceShop, DC, and PC1, so every data set can be pivoted with the same key. So let me switch over to the other screen. Just bear with me. There you have it. Just click that one and run the script. So first, it does pre-flight SSH checks to all hosts. If any box can't be reached, it fails it fast instead of giving me a fake demo. Now it fires off the tagged test activity across the lab, OpenSense sensor logs, JuiceShop web app logs, and Windows event logs on both DC and PC1. It also forces tagged failed logons on DC and PC1. Those show up as event 4625 and are marked as expected fail. So the script continues, as you will see noted there for DC and shortly PC1. So there's a paper that was released in 2025 called "When AI Ops Become AI Oops" by Pasquini at ETL. That shows attackers can poison telemetry and trick automated systems. That's why I tag and verify failures. The pipeline knows what's intentional before I ever investigate. Burst completed. So there's the printed tag over there. This time it's 32441. And next I pivot into Splunk with the index lab tag, and then drill into auth 4625 and the JuiceShop net probe nginx entry. Let me switch over to the Splunk screen. There you have it. So, as I said, first up is Splunk, right? I start wide, one burst tag pattern pulls evidence across the hosts and datasets. This gives me the investigation spine, and then I will drill down. Let me run this query. Now you can see the burst is spread across multiple hosts, DC and PC1, just to name a few over here. It's also across multiple source types, Windows logs, application logs, as you will see over here. And this is the bonus, right? I've got OpenSense sensor telemetry, landing 2, Circada, and Zen Armor right there are both showing up under 172.16.58 dot 2. So this table is my investigation spine, right? One tag pattern pulls the whole environment into a single timeline. Now, I pivot to identity auth, right? The burst forces a tagged failed logon that creates a 4625 event, and I want to see it on both the domain controller and as well as the endpoint. I'll run the search. And those are the results. We've got 32441, just like in the terminal. And that's the 4625 on the domain controller, as you will see right there. Both carrying on PC1 as well as DC, both carrying the same burst marker. This is the classic SOC question: is endpoint activity tied to a suspicious authentication event with this tag? Yes, it is. Next, I pivot to network plus app evidence. PC1 generates a net probe to JuiceShop, and I validate it from the application side using nginx access logs. Let me go ahead and run this query. There you go. This is the JuiceShop nginx access logs, filtered to uh, lab signal equals to net probe, as you will see over there. I'm using the burst tag pattern, lab burst version 3 underscore 5, and confirming origin by searching the role request for lab host PC1, as you will see right there. Um, so the proof is right over there with the source IP. That's my PC1 in the lab. You can also see the HTTP GET method right over there. And the URI contains the full tagged query string. So the tag is carried end to end. So now I have endpoint to app evidence that links back to the same investigation thread alongside the auth 4625 events we just saw. Now I pivot to Microsoft Defender for endpoint to confirm endpoint visibility for PC1, and you'll see over here that both PC1 and the DC are onboarded. Click, I'll zoom into PC1. Just go ahead and sign in again. Is timeline, and I'll search for, what's that? EICAR. I didn't even have to search for EICAR. It's right over there. EICAR lab burst, as you will see. So that's the endpoint evidence. PowerShell created the EICAR lab burst right over there. That proves the test action executed on PC1, and Defender captured it as a timeline event. So even without shipping Defender into Splunk yet, I can verify the endpoint activity directly in the EDR. So in about 5 minutes, about 8 minutes, Splunk gives the investigation spine. All failures show identity context. App network logs confirm real traffic. Defender provides endpoint visibility. So the next upgrade is that I'll be wiring my lab telemetry into Microsoft Sentinel. So Defender detections and endpoint context become first-class pivots in the same investigation thread. So that's about it for this walkthrough. Thank you so much for your time. I hope you have a wonderful one. Cheers.